Hello, welcome to another video. I just wanted to do a little explanation on why north wind and even a cooler air mass coming in doesn't always mean cooler temperatures at the surface, particularly in areas near the coast in the Bay Area that are typically heavily influenced by ocean air. And I'm going to explain why when we get a north wind, it can actually make it warmer in some areas near the coast because of the elimination of that colder layer of ocean air. So we're going to start here with the satellite imagery from 2 p.m. on Tuesday, September 10th, 2 days ago. And this is what we had. We had low clouds hugging much of the Bay Area coastline, as you can see. And this little heart here is where, it's just a favorite. I didn't draw it, but it's a pin for where my home is. And you can see even here we had low clouds very near most of the day with consistent onshore wind blowing through the coastal gaps, and it was 68 degrees at my home on Tuesday. And we actually had pretty warm air aloft at about the 5,000 foot level on Tuesday, but we still had a pretty strong inversion layer that was deepening because we did have low pressure already approaching from the north, but we had that strong layer in place. So it was about 2,000 foot, 2,000 foot inversion layer. So above 2,000 feet, it was significantly warmer than it was at the surface. And I'm also going to show you the wind was a very west-southwest wind, and that is indicative of a lot of cool ocean air within that inversion layer spreading in, particularly to coast and bayside areas, even spreading inland as well. Although it was still pretty warm, still relatively warm inland on that day. Now I'm going to show you the temperatures. This was a maximum temperature on the afternoon of September 10th. And, you see mostly just 60s along much of the coast, some areas even in the 50s. Much of the bayside locations still also maxed out in the 60s. And you have 70s and just about 80 degrees in the warmest inland spots. But if I zoom in here, I want to show you something. So this is Tuesday. The highs on Tuesday. So you look at this station at the top of Mount Tamalpais at 2,300 feet elevation, had a maximum temperature of 70 on that day. If you look down the hill, 1,000 foot elevation station, Hogback Road, run by PG&E, the max temperature that day was 61. So you can clearly see this inversion layer where this is 2,500 feet at the top of Mount Tam. It is warmer than it was in the valleys below. But now watch what happens the next day. Now mind you, the next day what happened is we had north wind come in. So this is what happened with the wind the next day. See, notice Tuesday was like west-southwest. Look at the next day. Look at Wednesday. It's a northwest wind. This is a pretty significant northwest wind. And notice we have more shades of green here indicating strong winds above the 22 miles per hour range because we have a tightening pressure gradient. We had a low pressure system passing over Oregon and really tightening that pressure gradient allowing for stronger winds, but this was a drier northwest wind. And then you have less marine influence, that cold air over the moist air, cold moist air over the ocean is kind of pushed out a little bit by this northerly, more dry wind, and it's also moving down the mountains and compressing and warming as it does so. So look at what happened, what was going on at 2 p.m. on Wednesday. See, compared to Tuesday, you go to Wednesday and you see the northwest winds have wiped out a lot of that ocean fog. So, having that in mind, watch what happened with the temperatures now, going from Tuesday to Wednesday. Look at that. 67 degrees at the top of Mount Tamalpais instead of 70. So it was cooler on Wednesday afternoon up there, but 82 in Mill Valley. And the previous day, as I showed, it was in the upper 60s. So this is what happens when you wipe out that marine influence. Is even if it's cooling further up in the atmosphere, it can be warmer than down below because there's no more inversion, and it is like what most places experience is the air compresses and warms as it moves down through the atmosphere, particularly in areas where there are hills and mountains where that process can be accelerated. This is very different. This is what I mean by it can be a lot warmer in the coast and bayside locations at the surface, even when there's cooler air coming in aloft because of that north wind. So I'm just going to show you now the 24-hour temperature change for Tuesday to Wednesday. And see what I mean? Like coast and bayside locations, you're looking at much warmer conditions. But look at Mount Tamalpais, 6 degrees cooler. And then you go further inland and you have some readings like in the Central Valley, it was cooler. Higher elevations and areas far inland was cooler, but near the coast and bays, much warmer because of that north wind. So that's kind of what I'm talking about. And remember I mentioned it was 68 degrees at my house on Tuesday. It was 84 degrees on Wednesday. Just like that. Even though there was a cooler air mass coming in aloft, it was a north wind and it wiped out that ocean stratus layer and it allowed it to warm up quite significantly, warm up more than it did the day before. It wasn't hot by any means because it was still a cooler air mass aloft, but it was way warmer than it had been the day before. So that's what I wanted to show for today. Just wanted to touch on that. Found it interesting. And thank you for watching, and I'll see you next time.